So here are just some more examples. I like to do examples because that's really how, we really see the stuff in action there, so to say. Here's another one here. So we have another polynomial, right? This one has degree 3. That's the biggest exponent of x. The leading term, as you can see, is this term. That's where the biggest exponent of x is. The leading coefficient is -5, right? That's the coefficient of the leading term. And again, the constant term is 0, right? It's not there. I mean, since it's 0, so we don't have to write it. Then we have the next one below it, this polynomial. And this is again a polynomial of degree 5, biggest exponent of x. Notice the leading coefficient is 1, right? Remember, if a coefficient's not written, it's understood to be 1. It's understood then to be 1. And the constant term is there, it's 12. This is a monomial is technically a polynomial. I mean, it's a polynomial of one term only, but it's still a polynomial. So in this case, 5 is a polynomial. Its degree, though, is 0. As you can see, the leading term is just 5, right? There's only one term there, and it's also the constant term. That's good. Now, so those are just some examples. Are there any questions about this? Yes.
So the numbers, like say that like the number is 5, but like it doesn't like have anything like with it. So like it's just a standard number, then the degree is always going to be 0.
Right, unless the number is 0. So if instead of 5 here, I had a 0, then it would be a polynomial. The degree, though, would not exist.
Okay, thank you.
Okay, you're welcome. Awesome question.
Thank you.
Okay. Any other questions? Okay. All right, let's keep going then. Let me put this back. I can. Okay. Now we know how to add monomials, right? We just combine like terms. Well, when you add polynomials together, in the end, it's really just the same idea. When you add and subtract, polynomials, you're really just combining like terms, just like you would with monomials. Now, there are two methods to accomplish this. One of them is what we call the horizontal method. That's basically where you add or subtract like you do with numbers, and you just look for like terms, and you combine them. That's the horizontal method. The vertical one I like to do because it's a little more visual. But again, whatever method you decide to use, that's fine. I'm not going to take points off if you use the horizontal method and you do it correctly. I'm not going to take points off because the vertical method I like better. I'm not going to do that. If you do something correct, I'm not going to mark it wrong. And really, it's best demonstrated by example. Again, it really just boils down to combining like terms. So for instance, let's say we have these two polynomials, right? And we want to add them together, like so. Okay. I put it in parentheses like this just to make it look nicer. You really don't have to do that. As you'll see in the other examples, I actually don't do that. But again, what's nice is you can find like terms and just move them around because again, addition is commutative. So for instance, we have 7x squared, right? Are there any other x squared terms? Well, yeah, we have minus 5x squared. So let's put that over here, as you can see. Okay, next is 3x. Are there any other x terms? Oh, here it is. We have 3x minus 3x. That's down here. We have 1. Is there any constant terms? Oh, we have 5. 1 plus 5, good. Now what's left over? Well, the only terms we didn't use are x to the 4 and x cubed. Let's leave them here. In other words, you can't combine these two with anything. And now we just combine the like terms together. That's what we do next. Right? We have 7x squared minus 5x squared. This becomes 2x squared. Okay. 7x squared minus 5x squared, right? Again, we just combine coefficients. So we really what we're doing is 7 minus 5, which is 2x squared. 3x minus 3x. Well, 3 minus 3 is 0, so we just get 0. 1 plus 5 we know is 6. We have x to the 4, that stays. X cubed also stays, as you can see. Okay, and we just rewrite it like this. No, because we had 0 here. And it's really good to write your answer in standard form, which again, the term with the biggest exponent of x, that goes in front. And then next would be x cubed, then 2x squared, and then 6. Again, you want to write it so that when you read it from left